Okay, let's get started. This is the second video for the chemistry module in the Applied Scientific and Digital Literacy Canvas shell, and this is Dr. Anatoly Palmer talking. So we have already uploaded our example data set into Excel, and we have pressure in pounds per square inch, and we have volume in milliliters, and here is our data. Now, if you have three significant figures in your data, but it's in zero after the decimal point, and you'd like to have that reflected in Excel, you can highlight your column, you can right mouse click and go to Format Cells. And instead of general, we could say number, and we can say how many places after the decimal point. And if we say 1, that means that all of our data now will have 1 digit after the decimal point. So you can do that if you would like to reflect three significant figures in your data for the volume. Now, if we want to graph, remember, if I say graph pressure versus volume, then when we say that, it's going to be the y-axis data versus the x-axis data. So in this case, if I say pressure versus volume, we want pressure on the y-axis and volume on the x-axis. So how do we go ahead and graph that? So we graph a scatter plot. We're going to highlight the pressure and volume data points. We're then going to go to Insert. We'll go to the charts and we'll do a scatter plot. Now, if you use just the dots, it doesn't draw a line for you. If you use this will connect the dots for you. Okay, it's not the prettiest of plots. You can see that there's some data points that's not quite falling on the hyperbola here. But basically, we can see that we have a nice curve, and we have from 0 to 70 on the y-axis and 0 to 40 on the x, but it looks like pressure is on my x-axis and volume is on my y-axis. But if you remember when we'd spoken, we wanted to try doing pressure versus volume. So to change the axes, because right now I have volume versus pressure, to change the axes, then what we'll do is you can use the right mouse button and click on one of your data points on the graph. And then what you can do is say select data. Now this is a series. You want to edit the series. And now you can see this says series name. You can add a name if you'd like. But my x-axis, the x values, it says is the pressure. So what I want to do is you can highlight that button and you can see how it's showing you what the x-axis is. And now instead, highlight what you want to be on your x-axis. And then for the y values right here, click on the up arrow and then highlight your y values. And when you do that, click on OK, then OK. And now you can see that on my, let me just move this up slightly, on my y-axis is the pressure. And how can you tell? Because it's basically going from 15 to 35. And those are the values for pressure. Okay. Likewise, if you want to put in a chart title, just highlight that, and then you can cross it out and say this is pressure in PSI versus volume in milliliters. Okay. And once you click out of there, see this plus sign? If you click on that, you can add more chart elements. And one of the chart elements that would be useful to have are axis titles, so you know what is my y-axis. So when you click on it, you'll use the up and down arrows. And again, you can say this is pressure in PSI. And you could put a label on my x-axis, and this is volume in milliliters. Okay. Now, what else can we do with our graph? Well, another thing is maybe we don't want to start at 0, 0. There's a lot of wasted space here. So if you want to change your values, then what you can do is you use your right mouse button. Let me click on that again and click on the y-axis. And then you can say Format Axis. Use your left mouse button and click on this. And now to the right, you're going to see that the bounds, the minimum is 0 and the maximum is 40. If we want to get rid of some of this wasted space, we can start the minimum at 10, and then the maximum we can leave at 40. And then basically all these major units are 5 for the difference. We can leave it at 5 if you'd like, okay? Because that looks pretty nice. And then the minor lines, which we don't see, would be 1. Okay, so where do we see that? I'll show you after we take care of the x-axis. So here, again, we have wasted space. We could start at 20, and then our graph would fill up the space. So you right mouse button click, left mouse button to format axis, and we're going to change the minimum of our bounds to 20. And we can do the maximum to be 65, which it automatically did. And we can see the major units would be 5 intervals of 5. So that now takes up most of our space. So now we have a nice graph. It's labeled. We have a title. We have our units. If you want finer grid lines, if you left mouse button click on your axis, you can right mouse button click to get this box up, and you can say add minor grid lines. Now you can see where 26, 27, 28, 29, 30 milliliters are. So you would have a nicer definition. Okay, so that's how we do a simple graph, XY graph. Okay, and if we see that the data points aren't linear, in fact, this is a hyperbola, let's see what we can do. So what we're going to do is pause for a moment. I'm going to copy the data over, and we're going to actually do a graph of volume versus pressure. So we'll just take a quick pause. Okay, so what we're going to do is we're going to go down to the bottom tab, right mouse, we're going to click on it with the right mouse button, okay? And I'm going to move or copy this. So I'm going to click on with the left mouse button. I'm going to copy it, highlight the example, and I'll put the tab down here and say create a copy. And then I'll say okay. Now when we do that, you can see now I have the original one that we made, and I have a copy of that. So right mouse button click, I'm going to rename this. P versus V. Or do I want pressure versus volume? We're going to do volume versus pressure. And then we'll show you what we can do to try to analyze our data. So in this case, we're not doing pressure versus volume. We already did that. We're going to do volume versus pressure. So again, we're going to highlight the data we're going to use. In this case, what I like to do is instead of connecting the dots, I'll just have it where you just see the dots. Okay, so it's not a perfect hyperbola. Some of the data points, not surprisingly, not everything is perfect and ideal. So now we're going to go through, do the right mouse button click on my axis. We're going to format axis, click on that with my left mouse button. And instead of 0 to 70 here, I'm going to do 20. Okay, to 70 or to 65, that's even better. And then I'm going to do the same thing down below on the x-axis. and change my bound. So I'm going to start at 10. Okay. And if you click here, we can see that it's a much nicer graph. Again, we want to label it. So I'm going to click here, do the plus and get my axis and titles. So the chart title in this case is going to be volume versus pressure. And then when we click on our axis titles here, we can shift that up. We can say volume. This is in milliliters. And down below, this is going to be pressure. And this is going to be in PSI. Okay. And just double check, we can see it starts at 15 essentially, goes to 35. So we know that pressure is on my x-axis. Now, if I said, oh, look it, I wanted to find out what is, let's say, the volume at, oh, I don't know, let's say 24 PSI. Then if you use this graph, even with the line, you would have to estimate where 24 is and estimate what the value is of the volume. And it would be so much easier not to have to constantly look at the graph with its constantly changing slopes, because then it's harder to figure out what the values are. And instead, see if we can develop a linear relationship. Okay, so if this is the case, then one of the things that we can determine is that if the volume times pressure is a constant, and if that's the case, then let's see what we can do when we multiply them out, and after we do that, what kind of graph can we generate? So let's see if it's a constant. It looks like a hyperbola, but is it a hyperbola? So the way we can do that, okay, so P times V, okay? So that's the column C that we're going to generate. And the way we can do that, we're going to say that the first cell is equal to A2, that's the value that's in A2, times the value in B2. And then you hit equals. Okay, so again, if we want P times V, then we're going to say A2 times B2 and put the equal sign. So Excel knows to multiply these two cells. Now, what's nice about Excel doing your mathematical operations is if I put my cursor on this dark button down here, so I get the square, then with my left mouse button, I can drag it all the way down. And what it will do is it will calculate, follow that same operation, but calculate it based on these values in A and in B. And it does look like, more or less, there are some variations, right, with the 901 and 904, but look at, these aren't perfectly on a graph either. So let's say that it does look like it could be linear, okay? What that means is that P times V is equal to a constant. And if that's the case, then we can graph, if I said volume is equal to some constant times 1 divided by pressure, then that should be a straight line. Okay, so what we need to do then is I'm going to scroll down. Let me see if I can like move this up. Okay, so what I'll do is let me just scroll down or move this over. Okay, and now let me insert another column. So in D, I'm going to calculate 1 over pressure. So my units now are 1 over pounds per square inch. So just be aware, we do have to keep track of our units. The units for pressure times volume is pounds per square inch times milliliters. Okay, so just to make sure we keep track of all our units. Okay, so what we're going to do is to get 1 over P, P is A, and we're just going to say this is equal to 1 over the value in A2. Okay, so all we're doing here is getting the value for 1 over P. So now what we're going to do is if we're going to follow this graph, V is equal to constant times 1 over P. If we graph volume versus 1 over pressure, then basically we should get a straight line with the slope equal to the constant. Okay, so let's give that a try. So what I'll do is I'll put the graph below us here. Okay, so once we generate the graph, I'll move it so we can see it. So how do we get our data? Do we have to delete all the columns in between? No, what we're going to do is you highlight the volume. Okay, and if you hit the control button, you now use your left mouse button and you highlight the second column. Once you do that, now you have your 2 columns of data that you want to graph. Then go ahead and say insert. We'll do the scatter plot and I'll show you with just the data points on there. Okay, and this is the data graphed here. All right, now let's go ahead and check what we have here. Now, if you look, this looks like 1 over pressure, okay, is on my y-axis, and on my x-axis is volume. And now we didn't want that. We wanted volume versus 1 over pressure. So let me just highlight the data, use my right mouse button, go ahead and say select data. We'll edit that. And now on my x values, I wanted 1 over P. So not volume, but over here. Then for my y values, I wanted volume. So I'll highlight over here. And then I go back to the down arrow and click it. And I say OK. And I say OK. And now we have our line where volume is on my y-axis and 1 over pressure is on my x-axis. So let's go ahead and put in our axis titles. So my chart title is going to be volume versus 1 over pressure. On the axis title here, we know it's volume in milliliters. And here on this axis title, this is 1 over pressure, and that is 1 divided by PSI, are my units. Okay. Now again, you can see that there's a lot of empty space here. So let's say we start at 20 format, and for our bounds, we'll start at 20. Okay. And that hasn't changed, 20 to 65. And then here we'll start at 0.02. So, and I'll go up to 0.08. Okay. So now we have our dots and we have our data points. And then we have basically our axes labeled, and we have our title for our graph. So this is all good, but something's missing. So what could possibly be missing? And what is missing is like, it looks like a line. Let's find out. Does it have a linear relationship? So when I click on the graph and the plus buttons come out, then what we're going to do is click on the plus and we're going to go down to the bottom and say trend line. Okay. And then we're going to move to the right and we want it to be linear. We'll go to more options. So we see on the right-hand side is linear. Okay. is just generated automatically for the trend line name. And what I want is to display the equation on the chart, and I want the R squared. Now, what is a R squared? It's basically a correlation coefficient, and the closer the value is to 1, to unity, the more all your data points will fall on a straight line. If it starts deviating farther away from 1, then you may or may not have a straight line. You may or may not have a linear relationship. Okay, so here is the line of graph. Okay, so now that you have this, you say, okay, so I was supposed to just say 1 over pressure and then the slope, but what about the y-intercept, which is b? Well, the y-intercept's pretty small. Okay, so we'll just leave it there because why is that not equal to 0? The reason it's not equal to 0 actually is because we have data that doesn't completely fall in the straight line, and that small deviation has shifted your line ever so slightly. But this is how to optimize. When we do this, your Excel program will optimize, try to keep all your data points as close to the line as possible. So now you know how to generate a line of equation here, and we know how to compute the slope, and then we understand what R square means for it. Okay, now let's go ahead and use your equation to determine and interpolate and extrapolate data points. Now, if you do an interpolation, that means that the data point that you're interested in falls within the data set that you have, that you are given. If you extrapolate, then you're at these ends here where you're outside and you are assuming that that linear relationship holds true even outside your data set, which may or may not be true. Okay, so what happens is this. The reliability on a value from an interpolation, where it's falling in between your data sets, is much higher than any value that you predict from extrapolation. Because basically, while that may be a good data, we are assuming that that linear relationship holds true. So let's go back to our original question. What is the volume at 24 psi? So let me just move the question down here where we can see it again. Okay, and then let's take a look at our equation. So y is equal to some value x plus 0.1488. So y is the volume. We can see that it's the volume in milliliters. That's on the y-axis. So, and then the 881.98, okay, that does have an excessive number of significant figures, but let's just ignore that for now and just focus on the graph and doing my interpolation. So that, what are the units? Well, the units is like milliliters divided by 1 over psi, right? So how do we get this? So rise over run. Rise, the units are milliliters, over run, and the units are 1 over psi. And so whenever you're dividing a fraction like 1 over 2, it's the same as multiplying by the reciprocal. So these are your units for that, okay? And x, let me put that, let me just highlight y, okay? I'll put y in italics and x, which I haven't written in yet, okay? So x is going to be the 1 over pressure in psi, okay? So the units here will be 1 over psi, okay? All right, so that is our x value. Our x value is 1 over psi. I'll put that in bold, okay? And then it's plus, let me just finish the equation here, plus, and then B. So what is B? So 0.1498, and that's going to be my y-intercept. So that unit is going to be in milliliters. Okay. So why did I go through and put all the units? Because I want you to be aware now. If you are looking, let me just move that to another place so we know it's not related to our question. Okay. So if we are looking for the volume, we're looking for Y at 24 psi, then basically be aware that X is not equal to 24 psi. X is equal to 1 over 24 psi. So if we know that X is equal to 24 psi, then, or the question, let's say, is asking for 24 psi, then X is equal to 1 divided by 24 psi. So now you can plug that value. So we can say that the volume, this is going to be equal to, and you can just type out your equation, 881.98 times the 0.041667. We could do it that way, or you can say 98 times, and we're in I 27, okay? And then we'll say plus 0.1498, okay? So we expect it to be 36.9 or so, 36.9 milliliters if I'm at 0.042 for X. So now why did we do it this way? Suppose I say, well, I want 24 milliliters. I want a volume of 70 milliliters. I want a volume of 55. Let's do 47. We can do a whole set. Let's say 30. Oh, let's do 30. And then let's do like 20. Okay. So now that we have our equation, calculating 1 over, okay, this one is 1 over 24. So I just be aware, if I pull this down, that number is not going to change, okay? But what I'm more interested is in putting this value into my equation. So this was I-27. So let's just go ahead and say this is 1 divided by H-27. Okay. And now, if I pull it down, because I've specified H27, that value, then now as I pull it down, it will look at the following cell values and put that into the equation. Now, when I'm looking at I-27 to do this equation, it's right here. But now I can pull this down and it will look at all the values subsequently in the I column. And so if I had 20 for my volume, then basically it's 0.05, okay? And then basically the volume, or 20 is my pressure, so 0.05 is my 1 over pressure, and then my volume should be around 44. Okay, so these are all basically what is the volume at 24 psi, what's the volume at 20 psi. And you can see that this does a very good job of predicting it. Okay, so now what happens if we go the other way? Suppose I'm going to ask you the same question. Now that we're doing all these calculations, suppose I ask you a question instead saying, what are the pressures in PSI given the following volumes in milliliters? Okay, so suppose I gave you, let's say volume in milliliters, uh, and suppose I say, oh, I wanted Let's go 15 milliliters, 22 milliliters, 28.5 milliliters. Let's do a few more. Let's do 52 milliliters. Let's do 75 milliliters. Okay, so 75 is definitely extrapolation, 20 is an extrapolation, but the other values are within our data set. Okay, so now volume is the Y value in here. So what we're going to have to do is solve for the pressure. So to do that, let me just scroll up here so I can show you what I'm going to do. From the volume, hold on a moment there, from the volume, I'm going to subtract the 0.1498. Okay, so once it's on this side, I can now divide it by the volume here. So 881.98. Now what that's going to give me is 1 over pressure in PSI. Okay, but I don't want 1 over pressure, I want the pressure. So we're just going to do the inverse of everything. So if I take 1 over pressure, so the pressure is going to be equal to, and I'm going to invert, right? I took the reciprocal of this part of my equation. Let me just highlight. So if I take the reciprocal of this part, and put this in bold, okay? Then what that means is I have to take the reciprocal of this part of my equation, okay? So to take the reciprocal of that, the pressure now divided by 1, so the pressure is going to be in PSI, is going to be equal to 881.98 divided by the volume minus 0.1498. So now that we know how to calculate it, we can now write pressure. That's going to be PSI. We're going to take this as H36. We're going to start with there. It's going to be 881.98 divided by, and we're just going to copy over the equation that we just developed, H36 minus 0.1498. Okay, and why didn't it work? Because you know what I forgot? It thinks it's text. It doesn't know I want to do an operation unless I put an equal sign. Once I put an equal sign, I will have, well, if I don't randomly click on everything, I'll have a value. Okay, and that's my pressure. So now that we have our equation developed, okay, so 881.98 divided by H36, which is my volume, minus the 0.1498. So now that looks good. I just pull it down, and now it's calculated out all of the values, the pressures and PSI for me. Now again, suppose you say, well, wait a second, this is all well and good, but I want it to have only 1 digit after the decimal placement. I'm going to have problems with this many number of significant figures. Then highlight your numbers, right mouse click, go down to Format Cells and click on the left mouse button, and then go to Number and say, I just want 1 decimal placement. Say OK, and now your values look much better. And we can do the same here. Since X is part of my calculation, we don't need to round this, but once I get to volume, which is my final answer, again, right mouse button click after I highlight it, right mouse button click, left mouse button click on the format, say I want 1 after the decimal placement, click on that, OK. And now you have everything in 3 sig figs for the first set of calculations and 3 sig figs for the second set of calculations. So this is exactly what you're going to do with on your assignment with another data set. You're going to import it into Excel and you're going to generate your scatter plots. You're going to develop a plot that's linear, get the line of equation and your R squared. It's always important to know, is it linear or not? And then from there, you're going to interpolate or extrapolate some values. Okay, good luck.